Well, I'm Donna, and it's great to be able to look out and see all your faces, and so I'm really delighted to be able to introduce our next speaker, Stephanie Shipp. And I think I'll leave it there and send it a really technical introduction for Stephanie, and she's going to talk about really cool stuff. She is the Deputy Director and Research Professor at the Social and Decision Analytics Laboratory of Virginia Tech. Stephanie, thank you.
Well, thank you for having me here. Imagine if you've fallen asleep for 25 years and you wake up. What is your community going to look like? More importantly, what would you want it to look like? So let me tell you a little bit about what I'm going to do for this talk. I'll first tell you a little bit about myself. And then we've already heard a lot about self-water data. And actually, preparing for this talk, I sort of wanted to understand that too. We all know what they are, but what are they? And so I wanted to talk about after growing up in Germany, Ohio, and California, I've been a native Washingtonian since the age of 14. I went to Trinity College, now Trinity University in D.C., then on to George Washington University for a master's degree. And then about 15 years later, when my daughters were in middle school, I decided it was time to go back and get a PhD. All my degrees are in economics. So I spent the first half of my career in the federal statistical community. I worked at the Federal Reserve Board, the Bureau of Labor Statistics, and then the Census Bureau, and actually during the 2007 But because I did go back to school, new opportunities presented themselves, and my career shifted. I brought all of my statistics and economics background, but I also got to join the science and technology world, which I found quite exciting. So I had 8 happy years at the National Institute of Standards and Technology, and then moved on to a small federally funded research and development center called IDA Science and Technology Policy Institute, which does policy analysis for the White House Science Advisors. And then I was invited about 3.5 years ago to create a startup lab at Virginia Tech, and we're located here in Arlington. Our mission is to embrace the all-data revolution by studying the social condition quantitatively at scale. So we're an intentional collection of social scientists, social behavioral scientists, and statisticians, unlike many of the other big data labs that you might hear about in New York and Chicago. So we're a little bit different, and I hope that my examples will begin to explain that. But I wanted to also talk about my professional associations because they've been an important part of my career. Although I'm an economist by training, my professional home has been the American Statistical Association. And as you can see, I've been pretty active in a lot of the women's groups there as well. I will have to say they've been a source of inspiration where not only from a perspective of networking, but also learning how to be a leader and also just tremendous sources of friendship as well. The one thing I really liked about the American Statistical Association is I got to know people across all disciplines, and so that part I found really exciting. When my career took a shift to the science and technology side, I became active in the AAAS, and so it's pretty much active between the two, and being an economist, of course, I have to belong to the American Economic Association, which I do attend their conferences. But my last community is also really important to me. My whole family's been pretty active, and I'll have to admit that I probably no longer do road racing. I'm more likely to be doing yoga and walking. But for my whole family, this was an important part of our community as well. So we can come back to this in a while. Just place that in your mind. What is your community, and how do you think about it? That's what I was, if you close your eyes and think again, now 25 years, why is that hard? Why is it hard to think about what the community is? That's because we belong to so many different communities. So when you think about 25 years out, you have to think, okay, we're in my work community, my play community, my family. All all of these. And so, what do you think will help us do this? Do you recognize this? It's all about the data. But as we've been hearing today, we have vast amounts of data. And what our lab looks at are all the data that we generate just by going through the course of our daily data. So you go to get a driver's license, you pay your property taxes, you call 911, you're using government services, you're on social media, we're collecting that data. You're walking, you have your Fitbit, you're walking to the grocery store, you're tracking how many steps that takes, or how many steps it takes to get to work, or if you get off the bus but stop early, you're counting those steps. We're counting things all the time. And so we got really excited about a lot of this data. But I'm going to digress for just a few minutes because I'm not a philosopher like Claire, but I really actually did start thinking about what are data. So what do you think came first, data or computers? Data. Okay. Well, in 1613, the word computer was created, and it was a person who performs calculations to computation. 1640, the word data was created, and going back to even what Claire was saying, any fact, and notice the word assume as a matter of observation. How many of you have seen the movie Hidden Figures? Okay. That's actually what really spurred me to think about it, because up through the early 1960s, we referred to people who perform computations and calculations with computers. It was a little shocking in the movie when they were referring to women who geniuses as computers, but it was completely accepted. Today, that probably would not be so. All right, I'll just tell you now, it's a trick question. Which of these are data? How many of you say all of the above? Well, the way I would define that is I would say none of the above. But I said it was a trick question, so it's not very obvious. So if data are a matter of observation, what do we need to make an observation? Well, we need questions. We need to start with questions. And then how do we create a direct fact from an observation? And we do that through measurement, and that's what forms our foundation for data collection. So pretty basic, but I don't know why, I just really had to try to understand this and work through it. And of course, from our data collection and our questions, we can then do our synthesis, exploratory analysis, and use that to inform our statistical models and our learning and our information. So, that being said, we like to put our data we like to bin our data into 4 buckets. The first is our traditional design data, the survey collections, the experiments, the data that we collect from telescopes, the observational data. Those are the data I think we're all pretty familiar with. Then there's the administrative data. And at the federal level, it's been recognized how powerful these are. But what we were really excited about when we walked outside our front door and started interacting with the local government workers, the program leaders and the agency leaders, is that there's this vast wealth of untapped administrative data at the local level. And we got pretty jazzed about that. Then the third bucket of data that we're using, and I hear a lot of you using as well, are the opportunity data. So, it's our Fitbits, it's the GPS, it's all the tracking that goes on. These data are really valuable as well because they provide very timely and more geographically granular data about human behavior. But they also face fraught with statistical challenges. So, of course, we need to use all these different kinds of data sources. And then we added a fourth bucket, which is procedural data, because as we've begun to examine communities within the Department of Defense, we realized that the processes and policies that shape our lives here is really important as well. And we were doing this in the context of looking at Army enlistees, which is starting the fact that almost 30% of young people who enlist in the Army, although it's no longer quite so young, you can enlist up to age 42, 30% leave in the first 6 months. So they've been studying this for a long time, and so part of what we're looking at all these different things. All right, so let's go back to our communities, and let's first focus on the fire chief. When we first came to Arlington, the fire chief was really excited. We question. And this example may be a little bit naive, but it's one that really tells the tale of the kind of work that we're doing. He asked us if it was possible to link end-to-end the 911 incidents through the data. We started thinking, we don't already do that. And his reason for doing this was, and we like this term, we borrowed this throughout our other analysis, he said, if I could do this, I would have a corpus of data that would help me improve my situational awareness. I could detect emerging trends, I could understand how the weather impacts 911 incidents and our responses to them. I could look at a variety of different factors where vulnerable populations are. So we undertook, and what we were really surprised about was that each of the sources of data from 911 incidents are in their own silos, or as we like to say, their own cylinders of excellence. Each one may be a beautiful piece of data in and of itself, but it does not connect. There is no way to, there's no obvious way to connect this data. Obviously, we were able to do that. So just to show you, the data come into the CAD center, that's up here. Well, that creates one silo of data. The units are deployed, the fire engines and the medic units are deployed, and there's a lot of automatic data collection going on as well. Then there's after action reports. So every unit that goes out, you often see a fire truck, the medics in it, and other units go out. Each one of those files an after action report. This is about one incident. And then there's sometimes social media. In Arlington, they don't formally use the social media. They're interested in trying to figure out how to use it, although if you read these two, you can understand why they don't right now, but they can be a signal, and we're going to be working with them on that. I will have to add that, and if you've noticed, I've been using the term all data, not big data, throughout the presentation, and we like to talk about the data are not always big, but they're always messy and complicated, and it takes you about 80% of your time right now to figure out how to clean these data, link these data, and then get to the fun parts of the analysis. Well, we have to say, we sort of like these other parts too, but what our lab is all about is creating the science of data science. So what we're hoping to do is move that needle from the 80% point down to the 50% point. And by automating a lot of the data cleaning and profiling and wrangling the data, perhaps we'll have more time to be able to get to the analysis faster. And as we keep working problems, we'll be able to do that. But it's, so anyway, you have to love this if you're going to be doing it. So let me just give you a few examples that we were able to answer for the fire chief by, let's see if we can get the movie. He said to us, we always feel like we're at a medic unit, and I don't know how to measure this. I don't know how to go to our county board and say, I need more resources, but we're always at a medic unit. And we looked at the data and we're like, we're not sure we know how to do this either. But the first thing we did was, there's about 10 medic units and 10 engine units in Arlington for each of the fire boxes and fire stations. So we took 3 years of data and we mapped this time out on call over a 3-year period. And that's what you're watching here, is each unit out on call by every day over a 3-year period. And then down here what we're doing is when the blue, the medic units are all out on calls, it hits the blue bar and the engine units hit the gold bar. So we really didn't get much. We just had to do this to organize the data, to understand it, to go on doing statistical analysis. But actually, when we showed it to the fire chief, we like to say there was spontaneous combustion. He actually began to see trends even just in looking at the data this way, and it helped him understand. So we did some box plots for each of the engine units, and so the box plots here show that fire engines are out for a median of about 10 minutes, and there's lots of outliers, lots of false alarms, so you can really see that really they're not out very long. When they are out, and there is an incident, they're out for a much longer period of time. But the medic units, when they go out, I mean, there's a lot of false alarms too, but they're out for a much longer period of time, for a median of more like 1,000 minutes. So they really are being used a lot more than engine units. So just this simple analysis, the fire chief was able to, one, reallocate his resources, and then add the ammunition out to ask for more resources. So pretty straightforward, but it wasn't so straightforward to get to that point to be able to use the data. And now we can go on and do more with it as well. One more example from the fire chief, he asked us about what he called frequent flyers or loyal customers. But he wouldn't actually define that for us. So we made up our definition of saying it's anyone that called 3 or more times in a month. And there are people that call far more than that. But when we mashed this data up with geography, what we indeed discovered was it was really loyal locations. So it's senior homes, rehabilitation centers, vulnerable populations that tend to be more in an institutionalized setting. And so we looked at that, and that accounts for about 85% of the calls. What the fire chief did was he reprogrammed some of his resources and deployed a nurse practitioner to go out and meet with the senior homes, the rehabilitation centers. And he told them, he said, here's alternative services that the county provides that might better be used, and here's when you use 911 calls. So you began over a 6-month period to see those calls go down, and then after about 6 months, the nurse practitioner would go back out because either the staff had changed, people forget, you get back to old habits. But anyway, they were able to make better use of their resources. And his real concern is that every time you have an incident, is that you are sending out a fire engine, a medic unit, other units, you're stopping traffic, that's dangerous in and of itself. And so he's like, when you don't need to, why, let's try to reduce the incidents without jeopardizing anyone's safety. And so one of the very first things we did, this was actually, we just mapped the incidents by time of day and day of week. And as we began to watch this, we actually got really excited. This is just 911 incidents, and you're plotting it starting at Monday at 1 o'clock, and then it's going through the whole week. And you can begin to see the patterns change over time, and the weekends are different, the mornings are different than the evenings. And we realized that this was a surrogate for flows of people throughout the county. And if you could begin to mash this up with demographics, or begin to mash it up with even housing characteristics, you could begin to tell a whole story about Arlington. So without making you dizzy watching the whole thing, although when we were doing it with our students, we got pretty excited. We watched it several times, but anyway, we indeed did that. And so, one last fire, 911. I told you these were our early incidents, but our early examples, but they were ones that really set the tone for our lab, and so we were excited about them. Is that in Arlington, and I think in most jurisdictions, they have a program in which the firemen, because there's so few fires, go out and actually knock on doors. They have smoke alarms with them. They make sure you have a working smoke alarm, or any smoke alarm at all, and then they offer to install them. Also, if you have a smoke alarm that's more than 10 years old, we learned you want to get new ones. What they discovered in doing this was that about 1/3 of all households do not have a working smoke alarm. And so they came to us and they said, we've collected this data. How do we know if we're doing this in the most optimal way? And so what we did was we did mash this data up with the housing characteristics of the housing units in Arlington, and then we overlaid the demographic characteristics, and then we ran a regression model, a Bayesian logistic regression model, to be able to show or predict where in Arlington housing units were more likely to not have a smoke alarm. And so we were able to show, and that's where you see the red as you go, is that they really needed to spend more of their resources down in the southwest part of Arlington rather than in the northern part of Arlington. And so now they're still continuing to collect their data, and in 6 months or a year, we'll begin to look at that again and see. So I have one more example. We're going to shift gears to Houston and Rice University. Those were so this is looking at air pollution. And this is a good day in Houston and a bad day in Houston. Why do you think that is? What's Houston known for? All the oil, production of oil fields. So Rice University early on had done a study, and they showed that for every 20 parts per billion increase in ozone, that there's a 4% increase in out-of-hospital cardiac arrests. So these are aggregate statistics. I mean, it's informative to do that. In Houston, EPA has deployed 40 air monitors across Houston, and that's again because pollution is so bad. So these produce mammoth amounts of data. In DC, by comparison, we have 12 air monitors for that it is much more of a problem. When Rice did this study, they also had data for emergency room deaths, and they said that if you were outside during a high ozone period, and you had an out-of-hospital cardiac arrest, you were very likely to die. So this is a real public policy concern. But they really didn't know how to actually look at this across the geography or across by individuals to be able to actually implement policy. So we started with their data, and then what we did, I think I had this a little bit out of order, let me go to this one. We created a synthetic population of Houston. So at the time we did this, there's 4.9 million people in Houston, 1.8 million households, and 1.2 million locations that people go to during the day. They go to school, they go to work, they stay home. It's a pretty simple model. We were able to show the differential effects. So this is just mapping out families and where they go each day or on one day. And then what we could actually compute, again just showing one family, was the differential effects of ozone on each of the family members. And so you can, you have the children, you have the 41-year-old female who seems to be having the highest impact of the ozone. Anyway, we could do this, and we could show it by where I just showed you the geography for the cities. And then do a just very straightforward box plots of the initial statistical analysis that we're doing. And what's so interesting about this is really what the Rice study was able to show is like the median effects for just each day. We were able to map this out by hour a day and show the impact on individuals. So if you just take, for example, 11 a.m. on one day, the average ozone is pretty high, but you can see that there's a lot of people that are affected less than the median, but there's a lot of people that aren't. And so how Houston is able to use this data are that they can better prepare their emergency services, so that they're having Medicaid associated throughout certain parts of the city, as well as hospitals and medical workers know when they need to be prepared. The other, it's a pretty simple solution, is that when there are high ozone alert days, you can simply tell people to stay inside, especially if they're at risk. So, how are we doing in time? Pretty good? Okay, all right. Well, then we'll give one last very early analysis that we're doing. The Census Bureau, when we first started our lab, asked us if it was possible to use local data to replace housing and education data in the American Community Survey. So I'm not going to actually report on that. This is a spillover from doing that, is that we became very familiar with the statewide longitudinal data sets. These are data sets that each state produces that provides data for every child from kindergarten through 12th grade as their test scores, their demographics, their just everything that gets collected at the school level. So an interesting question was posed to us. In Jefferson County, Kentucky, they have had a policy to desegregate schools. In Mecklenburg, just go through that. In Jefferson, actually, County, Kentucky, in 2007, it was deemed that it was unconstitutional to base your desegregation policy or your school assignment policy based on race alone. And so what they did was they went back and they created a new policy that was based on income, education, and other demographic characteristics. So there was a change in 2007. In Mecklenburg County, North Carolina, actually just the opposite was happening. They began to assign students to schools solely based on their neighborhood. And so that was a change. And so our very, very preliminary exploratory analysis we just concluded was to try to look at what impact this has had 5 or 6 years later. So when you look at the 88 schools, these are bar charts presented as a color diagram, and each of the bars represents a school. So there's 88 bars here, so to speak. If you look at Jefferson County, you can see that almost every school has a mix of races. So the red represents the percent of white students, the blue is the percent of black students, and then the green, purple, and orange are the other students. So most schools are pretty diverse. When you go over and look at the change, the impact of the change that Eckelberg made in 2002, and about 10 years later, you still see some diversity, but far less than you see in Jefferson. So as I said, this is just the very first stage of we've gone through that 80% of getting the data clean and then beginning to figure out how to use the data. And now we need to use this and formulate our hypotheses as far as statistical modeling. But still, this is a wealth of data that states are now making available for use in analysis. So that being said, we have, as a result of our working with multiple agencies, developed what we call a disciplined approach to working with novel sources of data. Novel sources can be our opportunity data, they can be our administrative data, they can be our processes and procedures. We start by undertaking a very very wide swath of looking at what we call data discovery. We have a research question: what's the best data that we can use for research? And then we go through the data profiling, the data wrangling, cleaning up information, and then the statistical analysis. This model, well, seemingly pretty straightforward and it's used by all researchers, really helps guide our work when we're working with our students, which gets me to our lab, and that we're all about the data. This is a picture on our left, and this is ASU, the American Statistical Association, funded us last summer through an NSF research experience from the graduates grant. They funded 4 of our students in our data science and public good. And our goal for this program is to train the next generation of data-savvy workers to work both in and with local government. We like to say that if they can have these early experiences of doing that, that hopefully they will return and work at the local government level. And it's beginning to change even now, at least in Arlington, they're beginning about using data. So our goal for our lab is to build the capacity for data-driven governance at the local levels. This is happening in New York, Chicago, San Francisco. It's not happening in Arlington, Alexandria, Fairfax. It's happening in little bits, but it's going to require a whole shift in how they think about their data. We're excited because what we want to do is not have the noisy 3 or 4 people that show up at county board meetings driving policy. We'd actually like to be informed by the data, and our goal is to work with our governments to do that. And with that, we really believe that the democratization of data will create a new foundation for democracy.
We are looking at these things.
You are. I just created a lab at EC.
I work with Octo and I'm the point of contact for OUC. We had an analysis project, so I'll talk to you about that.
Okay. We are, in fact, they just asked us to consider looking at, you have a grade, GRADE, grade DC website, and actually using that combined with social media to see how, if that's working to inform it, or if there's other ways to do it. So yes, we're really talking to Dave.
Fabulous. Any other questions for Scott?
Yeah, I was curious about the school example of the North Carolina and Kentucky. Have you looked at any of the student outcomes as to hypothesis like does those schools that are becoming more segregated versus those that are becoming less segregated, is there a difference in outcomes?
So we have looked at the literature, and the literature points to that school outcomes are better when schools are more integrated. We're now at the beginning stages of just beginning to look at how we might model that and show that ourselves. And these data do provide test scores, what levels you're at when you pass the different grades, and all the way through K through 12. So that is the next step.
Hi, I'm Susie Hopeless. I'm an epidemiologist at Johns Hopkins. How important is having publicly accessible data into this process of making data democratic?
That's a great question. So we do work with a lot of publicly accessible data, but we also work with a lot of data that the agencies either provide to us or that we can access, that they allow us to have access to it. We do have, Arlington was very forward-looking and giving us what they call a master agreement, data sharing agreement, which allows us to have access. Now, we have a fortress of security that we undergo, and, we have to work within our servers and work with the data. So even when we're using actually public data, because we're mapping up so much, we still work with them. But I would say that for a lot of cities and counties that feel that the data sharing is what stops them, I would have to argue that you can get started with a lot of the open data and a lot of the publicly available data. So all the housing data are publicly available. For example, you can map that up in your community so that you can learn a lot about the community. But so it's a mix. And we're trying not to let that way because the more you do this, and we've even seen a shift in how people view access to data in the last 3 years. People are much more open to it, recognizing that, in fact, this is the way to the future. We did write a paper for the annual review of statistics on privacy, and we have a somewhat controversial perspective, although we took it from the life sciences field, was that in fact, we need to allow researchers access to the data, all the data, not redacted data, and we punish misuse rather than